You good? Go.
So today we're going to have a brief introduction to data structure. Well, data structure is actually a very huge topic. So I don't think we have time to go through each of the topics in data structure today. So we are going to talk about array, stack and queue, and tree, and recursion. So aside from, except for recursion, array, stack, and queue, and or tree are the most common data structure that we usually use when we are programming. Okay. So why should we learn data structure? Does anyone know what is data structure? Anyone? No. Okay. So we often hear that people study in computer science, computer engineering. They are all required to take the courses like data structure and algorithm. The reason why is that when it comes to programming or coding, these two topics are very important, that you have to learn the concept of that in order to write a clean and logical code. So if you ask me how to describe data structure, I will tell you that, okay, let's say running a program is more like running a factory. And in this factory, you have a lot of machines that manufacture different products. So if the data are the material, the inventory, then data structure is how you organize these inventories. So it will make it more efficient to use these inventory and apply it into the machines. That is more like, if I describe these machines, I will say they are more like the algorithm, that because they are designed to have certain output, and they are designed to solve certain problems. Okay. So last time we talked about arrays. So anyone here need me to explain the concept of array again? Not you. Anyone? So everybody knows how to use array, right? Okay, so what we see here is just a one-dimensional array. Can anyone show me how to declare a two-dimensional array or three-dimensional array? Anyone?
In Java, at least, I want.
Oh, you can write it here.
I was just in C. I
Oh.
don't know about C, but I know about Java. Should be C. So in Java, you use something equals new into array with just multiple square brackets. And more and more and more and more. How can we leave?
So can you show me how to declare a two-dimensional array?
Two-dimensional array, which is
What about three?
add a third set of square brackets.
Okay. Yes, thank you. This is good. And so here are the examples. So for these two-dimensional array, can anyone tell me what's the value of this right here. Anyone? I mean, this array is two-dimensional, and in this array, it has the number of 1, 2, 3, and 3, 4, 5. So what's the value of example 2, 0, 1?
1, 4. 1, 4.
Okay. Anyone? Oh, Victor.
Three.
This one? Okay. You sure? Okay, so for the first bracket here, it suggests, okay, this one. And for the second here, it says 1. So that's 0, 1, so that's 2. Okay. So this is just an example. So for now, I don't think you might need to use a three-dimensional array, but it is possible that you probably need to use it in the future. And the best application or the best example is actually Giselle's project. Subash is not here, and so for Giselle's project, she's using a Arduino to display an LED that has a 8 by 8 LED array. So in her code, she will have to create a two-dimensional array to control the LED lights. And some people also use the Arduino kit to build a rainbow cube like this. So in their code, they will need to use three-dimensional arrays. Okay, so next topic. Let's talk about stack. So a stack is like what it looks like. For example, a stack of book, and we will stack it like the picture here. So if you want to remove one book from this stack, what would you do? You want to remove this one or this one?
Top one.
Yes, the top one. So if you want to add another book on this, would you want to put it from here or from the top? Yes, both from the top. So stack is sometimes called a push-down stack. So it's a ordered list that its input or output of the data take place only on the top of the stack. Sorry, I should fix it. And so like this, if we want to add another item into the stack, we'll say, okay, we'll push a data into the stack. If we want to take one of the item out of the stack, we'll say we'll pop one item out of the data. Okay, so it follows a rule that is always said that this stack is LIFO, which stands for, anyone want to guess? What's it mean? Chin-chin.
Last in, first out?
Yes, that is correct. Okay. So stack is very fundamental to the operation of most modern computer. For example, when a computer is running like a for loop, before the next iteration begins, it will have to store the address of next instruction or the variable of or the variable. And so when the next iteration begins, it can go to the memory stack and find and pop the variable or the address of next instruction and keep running. Okay. So the other data structure, which is pretty similar to stack, is called queue. So similar, it's really like that, like we line up to people line up in the store to get some food. It works pretty much like that. And so different from stack, the input or output, the removal or the addition of the item takes place on the back and the front of the queue. So when I wanted to add another item into this queue, where should I have it? Anyone? I want to add another item into this queue. Where should I do it? At the back or the front?
The back.
Yes. So if we wanted to add another item, we will say, oh, okay, this is called in queue. Make that item into the queue. If we want to take the item out of this queue, we will do it from front. So it's in the queue. Okay. So that is, it has different rules from from stack. And so for the stack, it's last in, first out. And for queue, it is first in, first out. So for developers, it's very common that we have to use data structures like queue because, for example, if you want to develop a order system for McDonald's, you will want it to have all of the order in, like you have to serve the person who comes in first. Okay. So next we'll be talking about tree. Before we start talking about how are we going to use this data structure, let's take a look at what is a tree looks like. So it basically looks pretty much like the family tree, right? From here. So generally we'll say A is the root of this tree because this is the start point, right? So how many in this tree we will refer each member of this tree as a single node. We'll call, okay, node A, node B, or node C. And on the edge of this tree, we will, the node on the edge of this tree, we will say it, we will refer it as leaf, like I, J, E, F, or K, L. They are the leaf of this tree. Okay. So, although this is, we can see a whole complete tree right here, but we can also divide them into subtrees. So can anyone tell me how many subtrees are there in this tree? Anyone?
3?
Yes. Which are there?
B, C, and D.
So it is also an important parameter that we have to know about this tree is the depth or the height or level. So for this tree, what's the height of the tree? Yes, 4. So, what we are looking at is a bunch of binary tree. Can anyone tell me what is a binary tree? Just from looking at this graphic. Anyone?
A branch always has 2 values at max, 2 values.
Yes. So each node will only have 2 subnode or 2 children at most. So this is very useful when programming because if we place all these nodes in certain rule, it will help us to organize our data. For example, in here, we have, let's say, these are the index of array, right? And in each member of this array, they will have the data of the node and the address or the index of their children. For example, like this node, it has a value of 6, and there's on the node's right hand side, it has on the right hand side they have the node with value of the data of 8, which has an index of 3. So these are like the address of the children of each node. Okay. So in this tree, we can see that the children on the left-hand side always has the smaller value than the children on the right-hand side. So if I wanted to add one more node with value of 11, where should I put it?
On the right side?
Okay, on the right side, right? So where do you think I should put it?
Below the 9.
Below 9? Is it here or here?
To the right?
Yes, because it's larger than the node itself. Okay, so this is a very good example code for binary search tree. As we saw that the tree right here, it is placed in the rule that node with smaller value will be always on the left-hand side. And then if we place like millions of nodes in the rule like this tree, for example, if we want to find the minimum value out of these nodes, we can write a code like this. So at the beginning, we can see, okay, for this function, the output value, output type is the node. And if you want to call this function, you will need to give it a node to start with as the start point. And okay, so at the beginning here, it says if the root is equal to null, it will return null. This is just trying to rule out the circumstances that this node is like empty or there's no node. So okay, so if the root node here is not empty, it's not null, then they will keep going to see if the children on the left-hand side is not null. It means it has the children on the left-hand side with smaller value than the node. It will return the minimum node with return of minimum node on the left-hand side, because you can see that it's calling the function itself to find the minimum node with start point of the children on the left-hand side. Okay, so this is actually a recursive function that we will talk about later. So with this kind of data structure, it will be easier for us to sort our data or to find the minimum or maximum value of the data. So, okay, we were talking about recursion or recursive function. Recursion is a method of solving problems that involves breaking a problem into smaller and smaller sub-problems that it is small enough to be solved very trivially. So, and it usually involves calling the function itself. Okay, so let's try to write ourselves a recursive function. For example, if we want to, does anyone know what's a factorial? If f of n equals to this. Everybody knows that? Okay. So how would you do this when coding? If I need a function to do this. Can you show me?
Yeah, like the first thing you would do is like if n is equal to 0 and return 1.
Mm-hmm.
That's the base case.
Mm-hmm.
If it's not, you return n times factorial n minus 1.
Yes, that is correct. So these two examples are basically doing the same thing. They have the same output, but if you do it with for loop, it will probably you will need to write more code like this, and you will need to declare a local variable to store the value. But if you do it in a recursive way, you will only the code will look much cleaner, and you don't even have to declare a local variable for that. So it's a very convenient way to solve a problem like this. Okay, so this is another common example, the Fibonacci sequence. Okay, so it's very similar. Like for this sequence, if A0 will be equal to 1, A1 will be 1, and for any number that is greater than 1, AN is equal to AN minus 1 and AN minus 2. So, so from here we can see that it's also trying to rule out the condition that is more different. For example, if n equals to 0, it will return 1. If n equal to 1, it will return 1 as well. For n that is greater than 1, it will return it will call the function itself, with the value of n minus 1 and n minus 2. Okay. So, any questions so far? Questions? Okay. So, I guess